Good morning, students. So today we will have a little bit of understanding of the equations of motion. Okay, in physics, especially in class ninth, you deal with this particular topic. This comes under motion, laws of motion. Okay, so or you can also use it in motion in one dimension. So it starts from motion in one dimension and is applicable to a number of places. Okay, so there are basic three equations that we have. I'll first of all list them in front of you, and then we will see how we can go ahead with the derivation part of it. Okay, because it is sometimes essential for you to know that. Okay, so the very first one that you have is v is equal to u plus a t. Now I will be telling you certainly about what all these things are. So when we say u, it means initial velocity. Okay, when we are talking about u, we mean initial velocity. Okay, so initial means the beginning velocity at the beginning of the journey. So this initial velocity may be zero if the body is starting from rest, or if you are considering a part of a motion while the body is already in motion, so you can have a particular finite value of u which is not zero. Okay, so in any case u means initial velocity, and you must have understood that v is the final velocity. Okay, v is the final velocity, a naturally is acceleration. Okay, this is acceleration. Okay, now usually when we have the horizontal motion, okay, when we have the motion like this, it is usually not affected by gravity in that sense. So you use the term, you use the letter a, which shows acceleration. It is the normal acceleration. The only change that you get when it's a vertical motion like this, then this a becomes small g, which is acceleration due to gravity. Okay, so the reason for the acceleration is different, but overall a and g are accelerations. Okay, so that is there. And then t, obviously you all know it is time. Okay, t is time during which this motion has taken place. Okay, so having understood what all these things are, let us now go ahead with the second equation that we have. The second equation, once I will list them, then I will tell you how to derive them. Okay, so the next one is s is equal to ut plus half at square. Okay, this is the second equation of motion, and then naturally we have the third one, which is v square is equal to u square plus 2 times a into s. Okay, now children, you must know that in all these three equations of motion, most of the things that you find here are in terms of u, v, a, t is there. The only different thing, the only new thing that has come up here is s, and is this s is the displacement. Okay, so let me just write this down also. This s denotes displacement. Okay, this is displacement. Okay, so I'll just give you a few moments to have a look at these three equations, and then we will go ahead with the derivation of each one of these using this graph that I have drawn. Okay, so I'll first start with v is equal to u plus at. Okay, so let us go ahead with the derivation of the very first equation that we have of motion. Okay, I'll list the other equations once again once we have completed the derivation for the first one. Okay, so my first equation that we have is v is equal to u plus at. So how did we get this equation is what we are going to see now. So let us have a look at this graph first. Now this graph, you should not get nervous by looking at the graph. This is a very simple graph drawn between velocity and time. So what is happening is, if you start from here, let's say for example, which is my origin. Now this origin always means that we are having time also as 0 and the velocity is also 0. Okay, so had the motion started from this point, I could have taken u as 0. But we can all see that the initial point of this graph, this is our main graph. So this part of the journey, so let us say that if I use the letters A and B over here, okay, so this AB line that I have drawn on the velocity versus time graph, this line is actually showing me the motion. This is actually giving us the details of what kind of motion is taking place. So there are two things to observe, children, here. First of all, that when we are starting from here, suppose I draw an arrow like this just to show you that the motion is starting from here. So here, what is the time? Time is 0. Time is there on the x-axis. So as long as you are here, your time is 0. So at the beginning of the motion or at the beginning of the journey, what is my velocity? See, velocity is on the y-axis. So what is the velocity with which I am starting or with which the body is already moving? So it is u. So that becomes my initial velocity. Okay. Now, as and when we keep moving along this line, what it means is that we are spending time also and our velocity is also increasing, because you can see that this line is neither going parallel to the x-axis nor going parallel to the y-axis. It is inclined at an angle and it is moving up continuously at the same pace. Okay, so you can say that this angle that it is making with the x-axis, that is a fixed angle. So you can say that this is a uniform motion or uniformly accelerated motion, because you can see that the velocity is changing, but it is changing at the same pace. Okay, so let's say, for example, this is my initial velocity, and when the body reaches here, you can see that this becomes the final velocity. And how much time has elapsed between this particular velocity and this velocity? Or let me rephrase the question, how much time has passed? Look at the graph and tell me how much time has passed when the body changed its initial velocity to v. So essentially what I'm trying to say here is that how much is the time that has passed for the body to change its speed from u to v. Okay, so velocity of the body has continuously increased. In how much time? So you can see over here on the x-axis, the body started here, so the time was 0 when it started. Okay, the time was 0, and when we are considering the final point here, what is the time here? It is t. So naturally from here to here the time is t, so it is this time. Okay, so now this equation which is already written over here, we do not, remember children, we do not know this equation as of now. Okay, so I'm just going to erase this and I'm going to get this equation from this graph. Okay, so now I will write that u is my initial velocity. Similarly, I will write v as my final velocity. The time that has elapsed for it to move from u to v in terms of velocity, that is t seconds. Okay, so let me write this. This time is t seconds. Okay, now the moment you see that velocity has changed, then comes the term acceleration, because acceleration is nothing but rate of change of velocity. Okay, so I am referring to a as my acceleration, because this motion has acceleration in it. As long as velocity is changing, acceleration is there. Okay, so if you remember children, from the graphical analysis that we discussed, between any velocity versus time graph, how do you find acceleration? So acceleration is found by finding the slope of v versus t graph. Okay, so this is the v versus t graph that we already have. So we just have to find out the slope of this graph. So where is my graph? Don't look at all these dotted lines. These are for some some things which we will do later on in this lecture. So you just concentrate on this dark line that is moving from here to here. Okay, so if you want to find out the slope of this line, then essentially you will have to drop a perpendicular here, join it here. So you will see that this becomes the perpendicular. So let me call this as the perpendicular. Okay, for this triangle, right angle triangle, this becomes the perpendicular and this becomes the base. Okay, this whole thing becomes the base, and we all know that the slope of this particular line can be found out by doing perpendicular upon base. Okay, so I will simply write, so let's mark this point as C, for instance. So my slope will become BC upon AC. See children, this is the perpendicular and this is the base. So this is my BC, this is my AC. Okay, now I am simply going to express this same BC and AC in terms of what we need. Now what do we need? We need an equation which has A in it, which has U in it, which has V and T in it. Okay, so as of now I have got A only. Okay, so I need to bring U, V and T in place of BC and AC. So what is BC? Let's have a look. BC is this distance here, which I can translate to this distance. Okay, because whatever is this much, same is this amount, because this is essentially a rectangle. So I need to find out the distance between this to this. So isn't that easy? You see children, from origin up to this point it is V. Okay, and from origin up to this point it is U. So how much is this going to be? This is naturally going to be V minus U. Okay, so this is going to be V minus U. Let me use a different we have V minus U. Okay, because this entire thing was V and this thing is U. Okay, see, let me just for the sake of clarity, let me write this portion as U and this whole portion is V. Now you will understand it better. This much is U and this whole thing is V. So how much does this become? Naturally this becomes V minus U, because this whole thing minus this small thing gives you the remaining thing. Okay, so I am going to now write down V minus U in place of BC, because this is my BC. Okay, this is my BC, this is equal to this. Okay, upon AC. Now what is AC? AC is this line, this distance, and you can see it is T. Okay, from here to here it is nothing but T. So I am going to simply write down T over here. Okay, this T can go here, so you will have AT is equal to V minus U, which is eventually going to give you this minus U can come to this side, become plus U, so you have U plus AT. So this is my first equation of motion, and this is how you get it. So this is quite simple if you know the nature, if you know how to study the graph of V and T. Okay, so this is the first derivation that we have. Now we will move on to the next one, which is the second equation of motion. Okay, so let us go to that second equation of motion. So I'll first write that equation and then we'll derive that. Okay, so we have S is equal to ut plus half at square. Okay, S is equal to ut plus half at square, and you know the meaning of all these symbols. S is the displacement. Okay, now the moment this S comes into our thought process, we understand that S is displacement. Okay, now we have a velocity versus time graph available with us, and we have to get displacement. So if you remember again, when we were discussing the graphical analysis of motion, we discussed that in a V versus T graph, which is velocity versus time graph, if you want to find out S, which is displacement, you have to find out the area enclosed. Okay, you have to find out the area enclosed by the graph. Area enclosed by the graph. Now which graph? Again, This is my graph. Okay, from A to B is the motion depiction of the motion from A to B. Therefore, we have to find out the area enclosed by this line with regards to the x-axis. So if you see, children, this whole thing becomes the area enclosed. Okay, and if you notice, this is actually made up of two different shapes, geometrical shapes, if you have a look at that. So this is the first one, which is in the form of a rectangle. Okay, and this naturally is the second shape that we have, which is in the form of a right angle triangle. So when you combine 1 and 2, you get the overall area enclosed between this graph and the x-axis. Okay, so our motive will be to find out the area of these two parts, and that will help us in getting this equation. Remember again, children, not just because I have written this equation, that does not mean that we already know the equation. We don't know this equation. We have to derive this equation again using the graph. Okay, so now I'm going to erase this particular equation, and we will get back this equation after we have analyzed the area enclosed between the graph. So let us talk about the area enclosed, and it will be, so let's say S, which is the displacement. Let's say S, which is the displacement, it is going to be area 1 plus area 2, because just now we discussed that the displacement during this motion will be the area enclosed between the V versus T graph. So we have two areas because we have segregated this whole shape into two parts. So one is the rectangular part. What is the area of a rectangle? Area of a rectangle is length into breadth. Okay, but we will not write L and B here, because we all know that L and B, which is the length and the breadth of this rectangle, they have particular values. Like for example, if you look at the length, this is the length of the rectangle and it is T. So I am going to write T multiplied by, so length is over length into breadth. Now what is breadth? This is the breadth of the rectangle. You can see this is the breadth, and how much is the breadth? It is U. Okay, so I'm going to write U here. Okay, so the first area is over. Now comes the second area, which is the triangular area. So we have a right angle triangle, and the area formula is half into base into height. Now children, what is the base? This is the base and this is the height. Okay, and I told you already that this base is nothing else but this. Okay, because these are the two opposite sides of the rectangle. So how much is this? The same will be this. Okay, so this also becomes T. Okay, this whole thing is T. So half into base, which is T, into height. Now height of the triangle is only this height, from here to here, from here to here. So it is equal to from here to here. So this distance, I already told you, it is V minus U. Okay, so I'm going to write V minus U over here. Okay, so all these things are to be taken up from the graph itself. Okay, and this is an easier and a simpler way of derivation. So you see, our S now becomes a mixture of a number of things which we have to simplify. So S is equal to, now this T into U, I can easily write it as UT plus half into, now V minus U. Children, remember our equation of motion is V is equal, the first equation that we studied was V is equal to U plus AT. Okay, and you can use this equation also, or you can use the acceleration formula, which is V minus U upon T. Essentially these two are the same things. You just bring this T here, so it becomes AT, and then this minus U comes here, so it becomes U plus AT. Okay, so either way you can have a look at this acceleration simple formula also. So you will see that if I want to bring acceleration into this equation, now you see children, in this, as of now, A has not come in. You see, you can see U here, you can see V here, you can see T, then again U, T, S. There is nowhere where you can find A. we have to bring a, because remember our second equation of motion was s is equal to ut plus half at square. So a has to come in this equation somehow. So what we are going to do is we are going to replace this v minus u. If you look here, this v minus u can be written as a into t. Okay, so this t is already there. Okay, this t is already here, and in place of this v minus u I am going to write at. So at. Okay, now in the last line you can always write s is equal to ut plus half a t into t will give you t square. So s is equal to ut plus half a t square becomes your second equation of motion. Okay, so this is the way you will derive it. Now we come to the third equation of motion, which is altogether a simplification of what we have done here just now. So we'll just have a look at that third equation also. So the third equation, let me first write that equation for your help. So we have the third equation as v square is equal to u square plus 2as. That is my third equation of motion. And once again, let me remind you, you do not know this equation. You are not supposed to know this equation beforehand. You are going to derive it with the help of this particular graph. Okay, so for this we are again going to observe this same graph. Okay, and we are going to see that we can also find out the displacement during this motion. We remember we just now found out the displacement by finding out the area enclosed. So that area was segregated into two different shapes, and we took out the different areas and added them. At the same time, you can also use another concept, which is, if you consider the displacement under this motion to be the whole area, you will also see that this whole area can be taken in terms of a single shape, which is a trapezium. Okay, these are the two parallel sides. Okay, and these are the two non-equal and non-parallel sides. Okay, so you can see that there is a perpendicular distance also between the two parallel lines. So this, if you look at this a, b, and let me call this as c now. Okay, so a, b, c, o, if you look at this whole figure, this is a trapezium, and you already know that if you want to find out the area of a trapezium, it is half the sum of parallel sides multiplied by the height between them. Okay, so displacement covered during this motion will still be equal to the area enclosed, but this time the area of the enclosed figure is being taken as the area of the full trapezium. Instead of breaking it into two shapes, rectangular and triangular, we are taking the whole thing together. Okay, so a little bit of mathematics here. So we have s is equal to half. Now have a look, children, sum of parallel sides. Now what are the parallel sides that we have? We have this as one parallel side, so this is u. So I will simply write u plus because it is saying sum of parallel sides. Okay, the other parallel side stretches from here right up to here. So you can easily see this whole distance is nothing but this distance. Okay, so which is v. So I'm going to write v here multiplied by height. Now height basically means the perpendicular distance between the two parallel sides. So where are the two parallel sides? These are the two parallel sides. Which one is the perpendicular distance? This is the perpendicular distance, not this one. Okay, so this, you can see it is t. So I'm going to simply write t here. Okay, so everything is being picked in terms of u, v, t from our graph. Okay, this is a very simple looking graph. Okay, so now remember our motive is to come to this equation. Okay, we have got something to start with. Now let us try to express and change this into this. So the first thing that you should notice here, children, again is that this has t, u, v, s in it, but no a in it. We have to get a somehow into this equation. So once again, you can use that acceleration is equal to v minus u upon t formula. So now since there is no u minus or v minus u present here, so what we should do is we should take this t here and bring this a here, so that we can write t is equal to v minus u upon a. Okay, this t will come here, this a can come here, so we will have t is equal to v minus u upon a. So in place of this t, this whole thing will be replaced. Okay, so let me write this ahead in the next step. So we have s is equal to half, this will remain as u plus v. In place of this t, I am going to put this thing, so v minus u upon a. So v minus u upon a. Okay, now children, have a look. It is all mathematical simplification. 2 and a, they are appearing in the denominator, so these two things can come here to give us 2as. Okay, s was already there, 2a will also go to this side, cross multiplication. So you have 2as equal to, you can see here we have v plus u and v minus u, so this will give you v square minus u square. I have used the identity a plus b into a minus b is equal to a square minus b square. Okay, so this, the product of this is going to give you this, so I have applied the same thing here. So what do you have? You have v square is equal to, this minus u square can always go to the other side to become plus u square. So you have this. Okay, so v square is equal to u square plus 2as. This is what we were supposed to get. So this is how all the three equations of motion will be derived. Okay, so you must have a fair bit of a practice in terms of the derivation of these three. Remember, the same graph has to be used and they are all interconnected. All these equations, they use the similar terms u, v, a and t. It's only, the only difference is the way you are taking it up from the graph.